Yeah. Okay, I'm recording now. Thanks for letting me know. I really appreciate it. So that's for the introductions to the notebook. So what I'll be doing is I'll actually create a new notebook, but the notebook is not going to be for lectures per se. I want to try my best to maintain the integrity of this notebook. That's keeping it as pure and neat as possible. That not trying to amend anything here and making every changes in the new notebook that will be created. So what I'll call this notebook will be I'll rename it to say the Big Mart Practical. So that's Big Mart Practical. So the function of this new notebook now will be okay. Whatever we learn from here, we can actually visualize it here. So without actually making any change here. So this will just act as a form of guide notebook while we're actually seeing what we seeing the effect of our what do I call it now? Our codes in another notebook. So before I start, most of the time before I actually start working on any modeling task, what I try to do is first look through the data and try to see if I can understand what the identifier is and what the our target is. So from here now, this might seem like the identifier because it was named the item identifier, and when you scroll through, it actually looks like they are not they are not there are no replications or duplicates now in this. But what makes a good identifier is the fact that the keys or the identity are actually unique. So one of the ways we can verify this, so I'll just quickly say something like the practical notebook. So so this is a practical notebook. So I'll import our two major libraries, which is the NumPy as MP and import and that's so after importing those two, now I want to load the data sets. That is load this data set into pandas now. I'll just, in order to save time, I'll be copying some of the code to speed things up. So I'll just copy this particular code. As loading this particular data set now. So one of the first things I want to check is this item identifier actually unique? So the way to do that is called the Big Mart sales dot the item identifier, which is the column name. The item identifier dot unique. So the unique method will actually tell us, okay, how many unique values are there? Okay, from here, what we can see is that there are actually a lot of unique values present in the there are actually a lot of unique values present in the item identifier. But now I want to compare it with the length of the data set. So I'll just ask for the length of this particular identifier now, making use of the length keyword, the length of this with the length of the Big Mart. So what we can see from here now is that the item identifier does not necessarily mean it's the perfect ID for the data set. So making use of our default ID, which is 0, 1, 2, 3, like that, would be more preferred for the data sets as we go forward. But that is not Sorry. Okay. But that is just one aspect of this thing we have to look at. So from our checklist now, which is what we are following here, we have what are the steps for the checklist? The first thing we need to do is prepare the data. And how do we prepare the data? We start by cleaning the data. So we look into this data, and the first question we need to pose is, okay, is this data set actually clean enough? Looking through the data set, we could see some, if we just scroll a little bit down, we don't need to scroll all the way downward because there are about 8,523 data points on this data. And we can actually look through them all to decide on, okay, say, this is what is missing in all of this, and we'll still make use of pandas to make some of those major changes, and make use of pandas to make some verification. But we just have to make use of, I just prefer making use of the Jupyter Lab interface now to quickly overview the data to get a quick insight of what is going on. So first thing we notice, which is pretty clear, is that, okay, the item weight has some missing data points, which is this, like this. And then the item fat contents. And this is because I've actually done a quick overview of the data sets. That's why I know that, okay, there are some things wrong. So one of the things we realize is that, okay, the item fat has two items in particular, low fat and regular. And this particular value keeps iterating all the way till it gets to this now. Now, this low fat and this low fat are actually the same thing, but the data set does not necessarily depict that difference because you see them as two different things. And one of the ways to quickly overview this is when we say the Big Mart as the Big Mart sales, that's the data set now. And we ask for the item fat content. Okay, that's the package. The naming convention. We realize that, okay, it states that there are actually 5 unique values. That is the low fat, the regular, then there's the low fat with a lowercase, lower L and F for the low fat. There's the LF, and this LF actually stands for low fat. The LF actually stands for low fat, and the reg now, RAG, stands for regular. Now, this is another thing we have to ensure that we clean while we are working with the data set. And then looking at the item visibility, actually this column is very okay. Same thing with this. And I think actually some other missing. Okay, yeah, there's the outlet size which is missing. It has it's a ordinal form of data. It's a categorical data having medium, high, and small. Medium, high, and small. And there are a lot of missing data points in this data as well. And I think that is the listing. I believe that is what the data points are missing. So a way to quickly check this out is to say the Big Mart sales. That's finding the information or the values that are missing in the data set, how complete the data set is, how complete it is, and all of those quick information. You can make use of the info method, which generates the overall information of a summary information of the data sets, the values that are missing, and all of those quick changes we need to make to ensure that our data is clean. So the item weight actually has only 7,060 non-null values, meaning the others are actually null. The same thing with the outlet size. So for the missing value, what we have to do is we have to make those changes. We have to find a way to fill those missing spots. And we could actually do that with something straightforward, as simple as saying the fill now for the item weight, which will impute a particular value in the item weight. And that the item weight is this column here. It's a continuous column. And if we want to fill it now, there are several things we could fill it with. We could fill it with a value, any value actually that corresponds with a float along this axis. Or we could fill it with the mean value, which is what we attempted here, saying, okay, the Big Mart sale dot item weight dot fill now. That is, we fill the now value with the mean of existing values from the column, and we do that in place. And then we do the same, something similar actually for the Big Mart outlet size. And what we do is that since this is more of a categorical column, the values rotate around the medium, small, and the high. So what we perform here is a forward fill. And what that forward fill does is that it places the value in the position here. Like for instance, if it's performing a forward fill, any empty space it sees, it carries the value right before it and places it here. So in the missing space here, it will fill it with, say, small, high, small, medium, and it keeps doing that. Like that. It does that for all of the missing column. At the end of this particular changes, what we see is a clean the data set that is more complete and not clean per se, because we haven't actually cleaned the data set yet. What we've just done is we found a way to tackle the missing value problem in the data set. And maybe I should just state, we won't actually be finishing the whole of this notebook at one go. I think we should be stopping right before the before shortlisting models. And that's because I want to give everyone time to settle down and process these stuff themselves, irrespective of the fact that what I wrote here now will be okay. And so as I was saying, we won't be taking all of the points in the data. We would actually take the first major points in the steps involved. That is the data cleaning. We'll talk about data cleaning. That is for this particular class. We'll talk about data cleaning, future selection, and what future engineering is all about. And probably also see how future scaling affects the data. So we do everything that has to do with preparation of the data. After we're done with preparation of the data, in our next class, which will be on Saturday, we'll talk about shortlisting the steps necessary in shortlisting the promising models for the data sets that we are working on. Yeah, okay, concerning the question, what if we drop the null value? We can actually, if we wanted to. we could drop the null value if we wanted to. But one of the reasons why that is not always advised, and in the class, there's also an activity that I want you guys to check. There's another way to resolve that, but it's still going to be at the end of the note. The reason why we try not to drop the null values based on the size of the data set. Okay, now we have a data set of about 8,523 data points, right? The issue with dropping the point is, for instance, taking this now. Initially, we had an outlet size of that had 6,113 points, meaning there was approximately about 1,500 points missing. And it's the same thing with, almost the same thing rather, with this, which might be about 1,000 points missing. That is the item width. Now, the problem is this point does not necessarily, the missing point now does not necessarily cross-sect. And what I mean by that is that the item widths that are missing are not missing alongside the outlet size. And let me quickly show you what I mean on the data set. So if you notice on line 30 now, the item weight is missing. But if you go to the outlet size now, the outlet size, which is directly here, it isn't. But if we were to drop the column, this particular data point will be dropped alongside the item weight. And by the time you proceed with dropping all of this column, you might end up with a data set of about, say, maybe 4,000 to 5,000, which would have dropped a lot of relevant data from our listing. So we try to avoid that by looking for means of filling the empty, looking for other means of filling the empty, filling the empty futures, looking for productive means now. The means that we made use of here is just something that will speed up our work, because we ain't really talking about data cleaning now. Our major objective is to model the data. But in order to do that, we need to ensure that the data is well cleaned and prepared, engineered, the right features are selected, and all of this stuff. We need to put all of this stuff in place. And after putting it in place, we proceed. So one of the means that we can just use and do that is by applying things as simple as the fill, which fills the empty listing with a particular value, and the forward fill, which we use for the category tag column outlet size. One method that I gave you guys in the activities, making use of the difference in the item weights, like the, okay, let me just progress on this point. If you realize now, there's a quick a relationship between the data. If everything in the data has either the outlets in front of it, like there's a outlet something, outlets identifier, outlets establishment, outlet size, outlets location type. And what this just means is that, okay, the outlet is well, it's an outlet, but all of these data are kind of correlated. So basically, you can make use of the outlets now, excluding this particular one, of course. You can make use of the outlets to deduce a value that will fix, and that if you impute here, if you impute directly here, so I was making the man there. If you impute here, it would fill the, okay. Let me explain it. Let me explain what I just said. I don't think I was very clear. What I mean is that, okay, if you look at the data, if you look at the data set, the summary of the data set, one thing you realize is that, okay, there's a section called the item section, just as if everything here starts with an item identifier, item weight, item this, item that. But for the items now, everything starting with item, there's a specific column that is missing, which is the item weight. So basically, there's a way to make use of these other columns, that is the item identifier, the item part content, and all of this, to create a new model that actually predicts what value best fits this. And the best way to do that is after understanding the data set. That is after you that is after we are done with the course. At least we've gotten to the level of model selection in the course. You'll be able to insert and create a model that will do the insertion of value directly for the item weight, making use of the other future columns to make that prediction. And it's the same thing for the outlets as well, making use of the other complete columns now, like making use of the other complete outlet columns to make prediction on the outlet size. And maybe I didn't really, maybe I didn't really do justice to the explanation, but you will get it when you look, you focus more on the notes. So if you have any questions, please just place them directly on the chat, or I will attend to them as soon as I see them. So that's for the first. That's for handling the missing data. Now we just prepared the data, and thankfully there are no duplicate values in the data set. So we proceed to what's next. That is the future selection. Now, as I said when we were speaking in this slide, I said something about the future selection, doing with looking at the data set now, electing futures that I feel will best be suited for our final prediction, which is the item outlet sales. But from our data set, what we can tell is that everything is important, because as I said, the data set is split into two now. There's the item section, which is like all of here, okay, all of here. And then there's the outlet section, which is like all of here. And the item outlet sales makes use of the item and the outlets. Then the sales that the union of these two spaces produce to make prediction. Okay, sorry. Let me zoom my screen there. Is it much clearer this way?
Yes.
Okay. Please, if you just have any distance, just keep forwarding it to the chat. I'm not perfect, so I make mistake most time. For instance, the recording, I miss both first and second time. So going back to what we're talking about now, that's we've prepared the data set. We're talking about the item type. Okay, yeah, we're talking about future selection. That's selecting which features we feel are more preferred or better suits our final objective, which is predicting the item outlet sales. For now, there are no proper evidence for us to say, okay, this set of features are the best in performing this task. So we'll be skipping that particular process. Then maybe when we create a model, say a random forest classifier, we could use it to deduce the features that best, use it to deduce the features that best suits our needs now. That is predicting the target model. So the next thing that is on the agenda will be the future engineering. Now, from the notes here, future engineering is the process of transforming raw data into futures that better represent the underlying process of the predictive models. And what that is insinuating that when you engineer the features of a model, what you try to do is you try to reframe the value of the data to suit the model and not to lose its integrity. And what I mean by this is that, okay, for instance, say we had an age column in this data set. Well, I don't see how that is possible, but let's say, for instance, we had an H column now. You could engineer the features of the H column in such a way that, okay, say the age, between the ages in the ranges of fives. So say between 15 to 20 will be grouped in one category. Now, what you just did by doing that is you engineer the future from a continuous variable to a categorical one. So 15 to 20, 15 to 20 will be a category. 21 to 25, another category, 26 to like that. So by this now, what I mean is that when you engineer a future, you don't try to change the value per se, but you try to upgrade it. I think that's a better way to put it. You try to upgrade it in such a way that it's makes it's you try to upgrade it in such a way that it further improves the quality of the model and not degrade it per se, because you could actually think you are making use of an engineering feature, and the engineering feature will actually destroy the data set. I said actually destroy the data set as well, but it will actually destroy your final outcome, which is the prediction. So there are various forms of engineering features. That which I just stated about the age, that is converting continuous into categorical, is just one form. And you will see a lot when you go through this book, fundamental techniques of future engineering information learning. But some of the most common now is what we do for the label and the categorical encoders. But speaking from the one of the most features that actually encoded or sorry that actually engineered are the categorical features, and we do that in three ways. We make use of the label encoder, which is an encoding technique for categorical listing. But the key word here is that each label is assigned a unique integer value based on the alphabetic ordering. And when it does this, it does not take the categorical order into consideration. And that's the key word there. So basically, what label encoding does is that it encodes the data with the imagery that we have here now: red, green, blue, When it encodes this data, it does not actually place a specific value on its encoding. So red to it is just a value. So there's no specific order with in label encoding such. What I mean by order here is that, okay, red is over green. No, there's no order. What the form of encoding that actually places order is the ordinal encoding, and that one of the ways to keep that point in mind is with the key term ordinal. The key term ordinal. So ordinal encoding is an encoding scheme just like label encoding, but it places order in the mode of the mode in which it encodes a categorical value. So in ordinal encoding, say something like high, medium, and small, just like our data set which we have here, which we have the outlet size. You realize there's a specific order between small I and medium, in the sense that small come before medium and medium come before high. So if you wanted to encode this, you want to do it in such a way that maybe small will be a value, say 0, medium will be 1, high will be 2. And you can start with 1 or whatever value there's to. One thing that is just put in mind is that machine learning models are sensitive to the values you attach, in the sense that the higher the value, the more emphasis it places to it when it's making predictions. So that is just like a quick overview of the ordinary encoding. The last one will be the one-hot encoding. Now, one-hot encoding is it's like this other two, but it's quite better. And what it does is that it performs a form of present and absent encoding. So it's make use of a categorical value, right? And it's convert it into a form of array now, which is something like what we are seeing here with the apple, the chicken, and the broccoli. Now they are categorical values, but when you make use of one-hot encoding, what it does is that it converts them to futures. And on the new data code, the one stands for okay, this is present and this is absent. So you with one-hot encoding, you often have an array of ones and zeros. So you see something like 1 0 0 0 1 0 0 0 1, and if it keeps going, you still see something. You still see the same changes. So there's the presence of zeros and ones, where the ones represent present and the zeros represent absent, and they can only be a single one on the rows. So say between the apple, chicken, and broccoli, there is one, then yeah, there's just a single one. I think you guys get my point now. So the one represents, okay, this is present, while the rest are absent. And in a way, the ordinary encoding is the best form of encoding. It's just that it's more computationally expensive based on the kind of category we are encoding. For instance, this particular category we encoded here, that's the sorry, not encoded, we previewed rather. That's the item identifier. If you were to categorically encode this category with one-hot encoding, now you have about 1,005. This is the exact shape I think you have. Okay, no, the inverse. You have 8,523 rows with 1,559 columns. And now this might look this will actually cause a lot of problems. I'm really sorry. I'm just getting a message now that the classes that the video is going to stop anytime from now. So probably maybe we'll be having another session maybe tomorrow, because it's very late now and I don't want to take you guys' time. So I'll just send some quick notes on this encoders, so everyone still stays online and understand what I'm talking about. So I'm just going to be signing off for now. And thank you for attending the class, Laura. Good night.
Please, have you shared the notebook?
The notebook. The notebook is actually present.